This research compares the safety occurrences of the Boeing 737 and Airbus A32x families of aircraft, utilizing the International Civil Aviation Organization (ICAO) safety occurrence data from 2008 to 2019. The study aims to identify any statistically significant differences in safety occurrences between these two narrow-body single-aisle aircraft families. The Boeing 737 family has a long history, beginning in 1964, with the first generation including the 737,100 and 737,200. The second generation, including the 300, 400, and 500, began commercial operations in 1984, 1988, and 1989, respectively. The third generation commenced operations in 1997, with each aircraft in this generation effectively replacing a previous iteration. The fourth generation, the MAX series, represents a similar refresh to the 737 range, with next-generation engine upgrades and aerodynamic improvements increasing performance and efficiency. The Airbus A32x family includes the A318, A319, A320, and A321. The series started with the A320 aircraft, which first entered operation in 1988, and was similar in capacity and performance to the Boeing 737-400 at the time, and later the 800. Airbus. To compete with the smaller variants of the Boeing family, the A320 was shrunk to the A319, beginning operational service in 1996, which competed with the 737-300, and later the 700. The design was shrunk further to give the A318, entering service in 2003, which competed with the Boeing 737-600. Only one stretch redesign was needed to give the higher capacity A321, which commenced operations in 1994. Of note is that the A321 predates its Boeing equivalent, the 737,900. The methodology implemented in this work follows that of related previous research, involving a cross-sectional component, with two aircraft manufacturers and several key variables. Each of these variables, occurrence type, occurrence category, phase of flight, injury level, and number of fatalities, has two or more nominal values. The distribution of these values in terms of their counts across a variable is then compared, either to some expected distribution, a goodness of fit test, or between cross-sectional elements, a test of independence. Where the samples between Airbus and Boeing are tested for their independence, the appropriate chi-squared test was utilized. The data will be presented in 4 parts. The first 3 will look at aspects of 1. All safety occurrences, accidents and incidents. 2. All accidents, and 3. Fatal accidents. It should be noted that each consecutive set is a subset of the preceding set. The fourth aspect will compare annual fatal and hull loss accidents per million departures. The research question is, are there any statistically significant differences in the safety occurrences of the core narrow-body single-aisle aircraft of Boeing and Airbus? This study examines the safety performance of Airbus and Boeing aircraft by analyzing data on safety occurrences, accidents, and fatalities. The analysis covers various aspects such as the type of occurrence, phase of flight, and injury level. In terms of all safety occurrences, there is a statistically significant difference in the proportions between Airbus and Boeing when coded by type of occurrence, with Boeing having a higher proportion of accidents. The same pattern is observed when examining the phase of flight, where Boeing has more safety occurrences during landing. However, the distribution of accidents coded by phase of flight does not show a statistically significant difference between the two manufacturers. The study also looks at the injury level of all safety occurrences, revealing no statistically significant difference between Airbus and Boeing. However, when focusing on fatalities relative to the total number of safety occurrences, Boeing has 28% more fatalities than expected, while Airbus has 26% fewer fatalities than expected. This result is statistically significant. When examining accidents specifically, the distribution of accidents coded by ICAO occurrence categories is not statistically significantly different between Airbus and Boeing. Similarly, the distribution of accidents coded by phase of flight does not show a statistically significant difference. However, the number of observed fatalities in Boeing accidents is 18% more than expected, while for Airbus, it is 20% less than expected, which is statistically significant. Finally, the distribution of fatal accidents coded by ICAO occurrence categories is considered. Due to the small number of fatal accidents, a chi-squared test could not be conducted, but the observed differences are evident. The study highlights that the findings suggest Boeing has a higher number of safety occurrences, accidents, and fatalities compared to Airbus, particularly during landing and in terms of runway excursions. Further research would be needed to understand the underlying reasons for these differences. The study analyzed safety occurrences involving Boeing and Airbus narrowbody aircraft between 2008 and 2019, utilizing data from the International Civil Aviation Organization, ICAO. The analysis focused on occurrence type, occurrence category, and number of fatalities. For all safety occurrences, the proportion of accidents was 10% greater than expected for Boeing and 9% less than expected for Airbus. Mid-air collisions were 23% more than expected for Airbus, while runway excursions were 32% more than expected for Boeing. Regarding the number of fatalities, Boeing had 28% more than expected, while Airbus had 26% less than expected. When looking at just accidents, only the number of fatalities was statistically significantly different. Specifically, Boeing accidents had 18% more fatalities than expected, while Airbus accidents had 20% less fatalities than expected. The whole loss and fatal whole loss rates per million departures for Airbus have reduced more than Boeing over the past 15 years, at a statistically significant level. The study concludes that the sentiment, "If it ain't Boeing, I ain't going," is still true in relation to any other manufacturer, but not relative to Airbus. The findings also mirror previous studies suggesting Airbus is performing better than Boeing in terms of safety. Future work is proposed to conduct a collective case study on the statistically significant findings of this work. The paper discusses the development of the Airbus A320 family, focusing on its impact on aviation safety and technology. It highlights the significance of understanding past accidents and incidents involving both Airbus and Boeing aircraft to prevent future disasters. The study utilizes data from the International Civil Aviation Organization, ICAO, and the Boeing Annual Summary of Commercial Jet Airplane Accidents to analyze trends in aviation safety. The authors emphasize the importance of understanding the role of black swan events in aviation, which are unpredictable and high-impact incidents. They also discuss strategies for managing these events, as proposed by Nofday, 2009. Furthermore, they touch upon the issue of climate change denial and its implications for aviation, citing Cook, 2017. In terms of aircraft design, the paper delves into the history of the Airbus A320 family, detailing its development and evolution over time. It references works by Botti, 2012, and Cummins, 2020, to provide an overview of the A320's impact on the aviation industry. The authors also explore the importance of intelligent systems, AI, data analytics, and advanced technology in aviation for enhancing safety and sustainability. Moreover, the paper addresses the need for continuous learning from past accidents and incidents, using examples such as the 1988 crash of an A320 following an airshow flyby, as reported by Bechet, 1990. It emphasizes the importance of understanding the causes of these events to improve safety measures and prevent similar incidents in the future. Finally, the paper concludes with a brief biography of the author, Graham Wild, who has extensive experience in aeronautical engineering, aerospace engineering, and aviation technology. His research interests include intelligent systems, AI, data analytics, and advanced technology in aviation, focusing on enhancing safety and sustainability.